Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. Ritu Johar, your educator for this course, Some Basic Concepts of Chemistry. Today we will begin with lecture 9 from the course, but make sure you have watched the previous ones before viewing this one. In this lecture, we are going to continue with the chemical reactions and stoichiometry, wherein we will be discussing the limiting reagent or reactant, percentage yield, and sequential reactions. So first of all, we will begin with the limiting reagent. So what is the limiting reagent or a reactant? Well, till now what all you have been doing is taking the exact moles of the reactants, making them react and producing the products. But what happens if we take one reactant in excess? Yes, the reactant which is less, that is going to be consumed up and the excess reagent would be left behind, right? So that reactant which is consumed up completely in the reaction is called as the limiting reagent. So we define this as the reactant or the reagent which is completely used up in the reaction and determines the amount of product formed is called as the limiting reactant or reagent, because the amount of product is going to depend upon this reactant which is less in quantity, right? How much more you may take the other reactant, there is no product going to be formed. Fine. So let us see this with an example also. We are seeing this reaction from the past lecture, N2 plus 3H2 forming 2NH3. This is a very important reaction in inorganic chemistry wherein we prepare ammonia in the process called as Haber's process. Okay, so that is why this is being picked up. And now you all know the ideal condition for the reaction is that 1 mole of N2 reacts with 3 moles of H2 to form 2 moles of ammonia. But if we have 3 moles of N2, 12 moles of H2, then what is going to happen? With 3 moles of N2, only 9 moles of H2 can react, right? 9 moles, and how much NH3 would be formed? That would be 6 moles. So what would happen to the excess moles present? So basically we would be having 12 minus 9 moles of H2 left, which is 3 moles left. Whereas of N2 nothing would be left and ammonia 6 moles would be formed, right? So this N2 which is consumed up in the reaction is the limiting reactant, whereas the H2 3 moles left, this is the excess reagent, and the product formed is going to be in accordance with the limiting reagent, right? So how do we find the limiting reagent in the calculations? Well, the same reaction for you, and then we have a general form of a chemical reaction that A moles of A plus B moles of B forms C moles of C and D moles of T, right? So what you will do is you will take the stoichiometric ratio of the moles of A is to B, that is small a by the small b. And in case of the nitrogen hydrogen reaction, this is 1 by 3, right? 1 mole of nitrogen and 3 moles of hydrogen. Now, according to the question also, then you will see what is the ratio of the moles of A to B, and you say that to be X by Y. What I mean by that is what is given to you in the question. For example, in our question, we had taken 3 moles of nitrogen and 12 moles of hydrogen, right? So this ratio would be 1:4. So you have taken two ratios. One is the stoichiometric ratio and the other is the ratio of the moles which is given to you in the reaction. Okay. And now what you see is that if X by Y ratio is less than A by B, then A is the limiting reagent, whereas if X over Y is greater than A by B, B is the limiting reagent. For the nitrogen reaction, you can see that A by B ratio is 1:3, whereas X by Y ratio is 1/4. So X by Y is less than A by B. So nitrogen is the limiting reagent. And you have seen that previously also, that nitrogen was consumed up in the reaction and 3 moles of hydrogen was left. Right? So this way you can just check which is the limiting reagent in the reaction, and your calculations have to be based in accordance with the limiting reactant. If you take the reactant in excess, the product formed is going to be wrong, right? So let us try one numerical based on this concept. Identify the LR, that is the limiting reagent, and ER, the excess reagent, and also predict the amount of product formed in the reaction 7A plus 6B forming 3C plus 4D. And you are given initial moles 21 for A and for B 24 moles. Now with 7 moles of A, how many moles of B are going to react? 6 moles. So with 21 moles of A, how many moles of B are going to react? That is going to be 18 moles. So if 18 moles are going to react and we have 24 moles of B, this means what is the limiting reagent? A is the limiting reagent and B would be left in excess, right? So now the product formed, that is going to be in accordance with the moles of A. So from 7 moles of A, moles of C formed are going to be 3 in accordance to the reaction, right? And for D, how many moles? 4 moles. So for 21 moles of A, C formed would be 3/7 into 21 and D would be 4/7 into 21. So this comes up to 9 moles of C and 12 moles of D. So this is how you identify the limiting reagent and then predict the amount of the product being formed. Let us do another question so that the concepts are crystal clear. My only motive is that all your concepts should be clear, because the questions are so many, they are numerous, you have to attempt them yourselves. My objective is only to make the concepts very clear. So now we have in the question, methane burns in oxygen to produce carbon dioxide and water according to the following equation. So the equation is CH4 plus 2O2 forming carbon dioxide plus 2 water. And in an experiment, a mixture of 0.5 mole of methane was burnt in 2 mole of oxygen in a sealed steel vessel. You have to find the limiting reactant, if any, and then calculate the theoretical yield in moles of water. Theoretical yield means what you're going to calculate. Okay. So CH4 plus 2O2 forms carbon dioxide plus 2 water. So this is the given reaction. And according to the reaction, applying the mole concept, we have 1 mole of methane combining with 2 moles of oxygen and forming 2 moles of water. So these are all the moles we are writing which we need in the reaction, right? So 1 mole of methane requires oxygen 2 moles. So 0.5 mole of methane would require how much oxygen? Just 1 mole. And how much oxygen is given to us in the vessel? It is 2 moles. So which is the limiting reagent? It is going to be methane and oxygen is going to be the excess reagent. So O2 given is 2 moles and O2 required is 1 mole. Hence the limiting reagent methane and excess reagent oxygen. So I hope this is clear to you, and for all your stoichiometric calculations, after balancing the equation, first of all check whether any of the reagent is a limiting reagent, and then move on with the rest of your calculations. So now for the product formed, so 1 mole of methane produce water 2 mole, 0.5 mole of methane will produce how much water? This is 1 mole. Fine. So now in the last question, you saw the word theoretical yield, and one more term which you are supposed to know is the percentage yield, and what is the difference in these two. Okay, so theoretical yield of a product is the maximum yield obtainable as calculated on the basis of the amount of limiting reagent used, right? So I hope this is clear to you all. Like in the last question, what all the yield of the product we are calculating, that is the theoretical yield. But in actual practice, the yield which you have calculated may not come up as so. Why? For example, there are many reasons for it. For example, one of the reasons can be that the reaction is reversible. And if a reaction is reversible, when the product is formed, it starts forming back the reactants also. So the yield may not be as you have predicted from your calculation. There are so many other reasons which can be, but you just have to understand that the yield can be less, right? And then if the actual yield is less, then we use a term percentage yield, where the ratio of the product formed in the reaction to the amount predicted when multiplied by 100 gives the percentage yield. So percentage yield is actual yield divided by the theoretical yield into 100. So let us see one or two numericals on this topic also to clear in your concepts. The question says that NH3 is produced according to the following relation: N2 plus 3H2 forming 2NH3. And in an experiment, 0.25 mole of NH3 is formed when 0.5 mole of N2 is reacted with 0.5 mole of H2. What is the percentage yield? So your work would be, first of all, to write the reaction. If it is not, then balance the reaction. Then write the given moles of the reactants. In this case, it is nitrogen being 0.5 mole and hydrogen also 0.5 mole, right? And now what are you going to see? Yes, you are going to check which of them is the limiting reactant, if it is the case, right? So this is actually a shortcut to find the limiting reactant. So see this side, we are having a shortcut to find the limiting reactant, and this is only for the objective exams. You will not write it this way when you are giving a subjective exam. For the subjective exam, the way we discussed in the topic limiting reactant, you will be performing all the calculations that way. For the objective exams, what you do is, to check the limiting reactant, divide the given moles of the reactant which is given in the question, divided by the stoichiometric coefficient. And whatever number is small, that would be the limiting reactant. So you see with this example, we have nitrogen. So given is 0.5 mole. Stoichiometric coefficient is 1. So 0.5 divided by 1, this is 0.5. For hydrogen, the given concentration is 0.5 mole. So divide this by the stoichiometric coefficient 3. So what? H2 is a smaller number. So therefore H2 will be the limiting reactant in this case. Now whatever calculations for the product you have to do, you would be doing that with hydrogen, right? So if 3H2 gives NH3, then what is 0.5 mole going to give? This is going to be 0.33 mole. And the percentage yield, what is that going to be? So percentage yield is the actual yield over the theoretical multiply by 100. So the percentage yield comes up to 75%, right? So let us see another question. We have antimony reacting with sulfur according to the equation Sb plus S forming Sb2S3, which is antimony sulfide. So the molar mass of Sb2S3 is given to us to be 340 grams per mole. And what is the percentage yield for a reaction in which 1.40 gram of Sb2S3 is obtained from 1.73 gram of antimony and a slight excess of sulfur? So the reaction is already given to you. You have excess of sulfur, so the limiting reactant is antimony. So you are going to proceed in a very simple way. It's a very simple question. So we have the reaction with us. According to the reaction, 2 moles of antimony are going to give 1 mole of Sb2S3, right? Now, because the molar mass of Sb2S3 is given to us to be 340 gram, so you can find the mass of Sp also, right? So even if you do not know what is the atomic mass of antimony, you can calculate it from here because sulfur you already know. Fine. So that comes up to 122 grams. So multiply by 2. So you get 244 grams, right? So 244 grams of antimony is going to yield 340 grams of antimony sulfide, but we have 1.73 grams of antimony. So that is going to yield how much of antimony sulfide? So this is going to come up to 2.41 grams. And now the percentage yield is again actual yield over the theoretical yield into 100. So what is the actual yield? The actual yield is already given in the question, 1.40 gram. Theoretical yield, you have calculated this to be 2.41 gram. So multiply that by 100 and you get the answer to 58.09%. So I hope the topic percentage yield is now very clear in your mind. So then we will move on to the next topic. So the next topic is sequential reactions. So sequential reactions, there is going to be some sequence in the reactions. So let us see A plus B forming C plus D. Then C plus D is forming E and E plus F is forming G. Right? So what is this is happening is that the product formed in one reaction is being utilized in the second reaction, and product formed in the second reaction is being utilized in the third reaction. So such type of reactions, they are called as sequential reactions. So the series of these interrelated reactions, they are called as sequential reactions, where the product formed in the previous reaction is being utilized as a reactant in the next reaction. Right? So I hope this is clear with you. And now we are supposed to do the stoichiometric calculations for such type of reactions also. Let us learn this also with a numerical. So the numerical we have is that NX is produced by the following steps of reactions, that M plus X2 forms MX2. This MX2 reacts with X2 to form M3X8. Then M3X8 combines with N2CO3 to form NX plus carbon dioxide plus M3O4. Right? And the question says that how much M the metal is consumed to produce 206 grams of NX, and we are going to take the atomic weight of M, which is given in the question to be 56, N 23 and X 80. So now to deal with such type of questions, I have just divided them into a few steps so you can understand what is the way we proceed with such type of questions. It is not that you have to follow the steps in this order, but it is just to explain you how to tackle such questions. So the first step is obviously for anything, it is going to be balancing the reactions. So I hope this is not going to be difficult for you. Now the second step, we are given 206 grams of NX. So what we are going to do is we are going to convert this into the moles of NX which is being produced, right? So that would be 206 divided by the gram molecular mass, and the gram molecular mass for NX is going to be 23 plus 80, so this is 103. So the moles of NX are 206 divided by 103. So this is 2 moles, right? So the next step would be comparing the stoichiometric coefficients of the common compounds in the reactions. So first in the second reaction, we are forming 1 mole of MX2, whereas in the second reaction, 3 moles of MX2 are being used up. So what we will do is we'll multiply the first reaction throughout by 3 so that the amount of MX2 formed is consumed in the second reaction. Then compare the second and the third reaction. So here 1 mole of M3X8 is formed in the second reaction and 1 mole of M3X8 is utilized in the third reaction. So there, as both the reactions M3X8 1 mole, so we will not do any change in either of the reactions. So now from the third equation, what you get is that 8 moles of NX are being formed by 1 mole of M3X8. And according to the question, you had calculated that the product formed is 2 moles of NX, right? So 2 moles of NX, they are going to be obtained from how much M3X8? That would be 1 by 4 moles. From the second equation, what do you get now? That we get is that 1 mole of M3X8 we are getting from 3 moles of MX2. And how much MX2 we require to get this 1 by 4 mole of M3X8? That is going to be 3 by 4 mole of MX2. And the first reaction, 3 moles of MX2 are going to be coming from 3 moles of M, or 1 mole of MX2 from 1 mole of M. So 3 by 4 moles MX2, they are going to come from 3 by 4 moles of M. So this comes up to 42 grams of M is required to produce 206 grams of NX. So this is how we can proceed with such type of questions, going from one reaction to another, linking all the reactions together. So we have another problem, and this is a very interesting one. Problem related to parallel reactions. So what is a parallel reaction? When two same reactants form 2 or more products, such reactions are called as parallel reactions. And let us understand this also with a numerical, and this is very interesting one. So we have carbon reacting with oxygen to form carbon monoxide and or carbon dioxide depending upon the availability of oxygen. Find the number of moles of each product obtained when 160 gram of oxygen reacts with A 12 gram carbon, B 120 gram carbon, and C 72 gram carbon. These are not choices, these are the subparts of the question first of all. And then what will happen in this question is you have to see the keyword. This is availability of oxygen. So here what happens is that when carbon is reacting with oxygen, first of all, if the oxygen is less, then the compound formed is carbon monoxide. You will see in many of the questions in inorganic and organic chemistry also, that on incomplete combustion, carbon is forming carbon monoxide, and on complete combustion it forms carbon dioxide. So here when carbon reacts with oxygen, when the oxygen is less, it is going to be carbon monoxide, and when you have more of oxygen, then that carbon monoxide is going to further react with oxygen to form carbon dioxide. So let us see how we solve this question. So we have carbon combining with half a mole of oxygen to form carbon monoxide. So at T0, what you are given is 1 mole of carbon and 5 moles of oxygen. Where has this 5 come? 160 grams of oxygen is given to you. So this is 5 moles of oxygen. Okay. So 160 divided by 32 is 5 moles of oxygen. And when the reaction is complete, you can say when the carbon finishes, because with 1 mole of carbon, what is amount of oxygen reacting is 0.5 moles, right? So 1 mole and half mole, and we have 5 moles. So 4.5 moles of oxygen is going to be left behind, and carbon is going to finish off, and you are going to form 1 mole of carbon monoxide. So carbon is the limiting reactant over here, and oxygen remaining would be 4.5 moles. So what do we have now? We have carbon monoxide, oxygen, they are left, and carbon dioxide can be formed from this, right? So we have carbon monoxide reacting with half a mole of oxygen to form carbon dioxide. So at T0, what do you have? You have 1 mole of carbon monoxide and you have 4.5 moles of oxygen. And how much of the two are going to react? For 1 mole of carbon monoxide, required is going to be again half a mole of oxygen. So what will you have at the time of completion of this reaction? You are going to have 0 mole of carbon monoxide. 4.5 minus the 0.5 mole of oxygen, which is going to be 4 moles, and carbon dioxide formed would be 1 mole, right? So at the end of this complete reaction, what will you have? 1 mole of carbon dioxide and no carbon monoxide. Plus what would be left behind? That would be excess of the oxygen, which was 4 mole, right? So out of carbon monoxide and carbon dioxide, what is there? Only 1 mole of carbon dioxide is being formed. Now let us see if we have 120 gram of carbon, which is the second part, 120 gram of carbon, then what would the reaction scenario be? So the tip for the reaction was that initially use the reaction which was utilizing lesser amount of oxygen. So let us now do the second part. So now for the second part, we have carbon plus again oxygen going to react to form carbon monoxide. And because we have 120 grams of oxygen, so that would be 10 moles of carbon. So at T0, we have 10 moles of carbon and 5 moles of oxygen, right? So as 1 mole combines with half a mole, so 10 moles is going to combine with 5 moles of oxygen. So what we get is that at the completion of the reaction, whole of the carbon and oxygen is going to be consumed, and we will get 10 moles of carbon monoxide. And since no oxygen is left, so the only thing we get is carbon monoxide, that is 10 moles. And for the next part, we have 72 grams of carbon. So that is going to be 6 moles. So 6 moles of carbon is going to react with 5 moles of oxygen. So when the reaction gets completed, the 6 moles of carbon has to react with oxygen 3 moles. So 2 moles of oxygen are going to be left behind. Carbon is going to be consumed up and 6 moles of carbon monoxide are formed. That means that carbon was the limiting reagent for this reaction. And now, because we have 2 moles of oxygen, they are going to combine with the 6 moles of carbon monoxide. And what would the carbon dioxide formed be? So, after the completion of the reaction, now the limiting reagent in this case would be oxygen, right? Because we have 2 moles of oxygen, and this 2 moles of oxygen will combine with 4 moles of carbon monoxide. And we will be left behind with 2 moles of carbon monoxide. We will form 4 moles of carbon dioxide and nothing of the oxygen will be left. So finally, we will be left with 2 moles of carbon monoxide and 4 moles of carbon dioxide. So I hope this was an interesting question, an excellent use of all your concepts, a lovely question. I really liked sharing this with. So this would be all as for this lecture is concerned. In the next lecture, we would be discussing some concentration terms used in solutions. If you did have any problem while you were going through this lecture, or you have any comments or suggestions to give to us, you please do mail us at h2ochemistry@gmail.com. And if you've liked the lecture, please do click on the like link and also on the subscribe link plus the bell icon. Only then you are going to get a notification as and when we put up a new lecture for you. So if you've enjoyed with us, please do that. Please do subscribe to our channel H2O. Bye for now. Have a nice day. Enjoy yourself.